Good morning, students. Welcome to the next video lecture on the biostatistics. In the previous lecture, we have seen a few terminologies which is used in biostatistics, and these terminologies includes a sample, population, then sampling error, etc. And this sampling error we will be just dealing in little bit detail in the coming video lecture. And now you just need to know that when the sampling is done, some errors takes place, and that error is called as a sampling error. And this error might change the result to some extent, and this change we can just nullify that change by calculating some sampling errors. And there are the certain equations by which the error is calculated, and we will just discuss in detail later. Now we will just pass on to sampling. So there are the two methods of data collection. The one, it is a census method, and the other is a sampling method. So in census method, we are just giving importance to each and every individuals in a population. That for example, while taking the census, that is, census means a population size. If you want to determine how much population is there in a particular area, or how thickly populated is that a particular area is, we will just go to each and every houses, and we will just take the number of the individuals in each and every houses there, and we just collect the data respectively. Okay, so we are just giving importance to each and every individual in a population in order to collect the amount of the individuals, or how thickly populated is that area is. So each individual is given importance in this aspect of census method. Whereas in the case of the sampling method, we are just selecting the few samples from a population, and those samples will be the representative of that particular population. And the population, of course, you know, it is a larger group. Okay, and we will just pass on to the sampling method in detail. And the sampling method can be of a probability and the non-probability type. So probability sampling means that each member of a population has known for the non-zero probability of being selected. That means the individuals in a population is given the least importance. That means non-zero probability of being selected. And this method includes a random sampling, systematic sampling, and the stratified sampling. Whereas in non-probability sampling, the members are selected from a population in some non-random manner. It means the individuals are selected non-randomly. Okay, and that type of selection is called as a non-probability sampling. And the method includes a convenience sampling, judgment sampling, quota sampling, and the snowball sampling. So in probability sampling, we are just randomly selecting the individuals from a population without any criteria. Okay, in non-probability sampling, we are just selecting the individuals based upon the certain criteria. So for example, if I want the few students from a class, so class is considered as a population, and if I need the few students from a class to participate for a competition, I just simply call out the few numbers. So that type of selection is called as a random selection. Whereas if I am going to do a procedure of non-probability sampling type, then I will be just giving some type of short competition in the class itself, and those who excel in that competition, I will be just selecting them, or I will be just calling out the individuals who scored above 80% of the marks for the previous test paper. So I'm just putting out certain criteria based upon which I'm just choosing the individuals from a population. So hope that is clear for you. Okay. Next we will be discussing on the each type of this type of sampling in detail. So first we will discuss what is the random sampling in detail. The random sampling, it is a purest form of probability sampling. Okay, it is a purest form of probability sampling, and each member of a population has an equal and known chance of being selected. So I'm just selecting the few individuals from a population without choosing any criteria. Okay, so each an individual in a population has a equal chance of being selected. Okay, when there are the very large population, it is often difficult to identify the every member of a population, so that the pool of available subjects become biased. And for that reason, you can use a software such as a Minitab to generate the random numbers or to draw directly from the columns. So there are the certain methods which we use in the random sampling. For example, the certain softwares are used like the Minitab, and from which we just choose the random numbers. And the random sampling can be of the simple random sampling. In the simple random sampling, each subset of a specified size n from a population has an equal chance of being selected. Okay, so this is a random sampling. So it is a simple population or a single population, in that these are the small subset of population which are of specific size. Okay, that is a simple random sampling. Okay, for example, if we take the students who have joined the first degree course in our college, that is a population, and from that the subsets will be the students who have joined for zoology, the students who have joined for botany, the students who have joined for physics, the students who have joined for chemistry. These all single groups will be the subsets. Okay, so it's clear for you. The whole population example, it is the students who have joined for first year degree course. In that you can divide them into certain subsets. Okay, so that's called as a simple random sampling. And the steps involved in the simple random sampling is that to get a list or a sampling frame, this is very hard part, and it must not systematically exclude anyone. So it's very difficult to take this type of random sampling. So for that we just generate the random numbers, select one person per random numbers. We will just choose the certain numbers to choose the individuals as per the random sampling. And it is applicable when the population is small, homogeneous, and it is readily available. So simple random sampling is applicable only when the population is small and homogeneous and it is readily available, and all the subsets of the frame are given an equal probability of choosing, and each element of the frame thus has an equal probability of selection. Okay, so and it provides for the greatest number of possible samples, and this is done by assigning a number to each unit in the sampling frame, and a table of random number or lottery system is used to determine which units are to be selected. So again, what are the advantages of the simple random sampling? In the simple random sampling, we are easy to calculate. Then the simple random sampling is always an EPS design, that is, it has the equal probability for selection. EPS, it is a equal probability. EPS, it is a equal probability for selection. That is EPS. So equal probability for selection. And then So in simple random sampling, it is always a EPS design, and not all EPS design are simple random sampling. Okay, there may be the complex designs may also be available. So in EPS, the equal probability of selection is enhanced or given importance in random sampling. And what are the disadvantages of random sampling? If the sample frame large, then this is impracticable. That is, if the sample size or if the population size is large, then this random sampling is very difficult. And the next disadvantage is that the minority subgroups of interest in a population may not be present in sample if sufficient numbers for study. That's again another disadvantage. Then the next type, it is a systematic sampling. The systematic sampling is often used instead of random sampling, and it is also called an nth name selection technique. It is also called as a nth name selection technique. Then after the required sample size has been calculated, every nth record is selected from the list of the population members, and as long as the list does not contain any hidden order, this sampling method is so good as the simple random sampling. So instead of using the simple random sampling, it is more reliable to use systematic sampling. And its only advantage over the random sampling technique is simplicity and the possibly the cost effectiveness. The systematic sampling, it is costly effective. Systematic sampling relies on arranging the target population according to some ordering scheme and then selecting the elements at the regular intervals through that ordered list. For example, in systematic sampling, we are just arranging the individuals in a population based on their based upon the certain criteria. For example, I'm just arranging the individuals in a class according to the height, and then I'm just choosing the individuals based upon their height. That means I'm just using the criteria such as a height for choosing that individual from certain individuals from a group. That is systematic sampling. And systematic sampling involves a random start and then proceeds with the selection of every kth element from then onwards. So in this case, the k is equal to the population size divided by the sample size. So that is a constant that we are using, the k, for systematic sampling. That k is equal to the population size divided by the sample size. And it is important that the starting point is not automatically chosen from within the first to the kth element in the list. And for a simple example, would select the every 10th name from the telephone dictionary, and every 10th sample also referred to as a sampling with a skip of 10th. Okay, so we are just using criteria. We are just arranging the individuals in the ascending or the descending order based upon the height or weight or some criteria we are using it, and then every 10th individual we are just choosing it. So as described above, the systematic sampling is an EPS method, that is a equal probability for selection method. And because all the elements have the same probability of selection, it is not simple random sampling. Okay, because the different subsets of the same size is different selection probabilities. For example, the set has a 1 in 10 probability of selection, but the set has a 0 probability of selection. So likewise, this is the example. It is a picture showing the simple random selection, and this simple random selection the systematic sampling selection is also having the advantages and disadvantages. The advantages is that the sample easy to select. Second, the sampling frame can be identified easily. Third, evenly spread over the entire reference population, whereas the disadvantages includes the samples may be the biased, and if the hidden periodicity may be there, and the difficulty to assess the precision to estimate from one survey. Thank you.